For the design, I follow the slides. So we have the key, which is we have the top level for the key. No, not the top level. The module, the big module for the key is key input, which has key base, which has the finite state machine, clock divider, and also the keypad in decoder. So the finite state machines will just sort of like looping around and checking which column am I pressing. So if let's say I press this column right here. If I press, if it's gonna detect, okay, there's a row goes low because it's active low. One of these row goes low, then it will use that column, because when it scans through each column, it will turn off any other column. But if it's scanning while it's scanning that column, and if I press any row inside that column, it will pick that column and it will pick that 4-bit of the column, and then it will pick the 4-bit of the row and then input it to the decoder, and the decoder will determine, okay, which value is it, and then that value will get passed through to the hex, and the hex will just determine and pick the values. This is the first example. That works, and then pause. I just couldn't figure it out why there's like dots appearing there, but everything works perfectly fine, just the dots there. Reset, and I'm gonna load another one. Boom. Okay, that works. Pause. Reset. And the last one, let's see. Hold on. I think I did it right. Load. Okay. I think I click it right. Damn, I accidentally hit C twice, but yeah, it works. It works. For the design of this one, I just follow the instructions. We have the clock ladder divides the clock. Slower clock goes to the pin, the keypad, and then the other two, the 17 and 22, goes to display and updates of the hex. bunch of modules that have from the keypad that's handling the data from the buttons, and then goes to the hex. The hex I just use. The hex is the part here is basically the crawler from part C, and this is the part A of lab 3. This is part A of lab 3. This is the hex mode, going from 0 all the way to F, and if it's decimal mode, the first 9 here will be 0 to 9, and then we'll have 1 to 9, and we have 0 there, and the rest will just be the letter. Here's the hex mode. I'll just give an example, just 0, 1, 2, 3, 10, 15. Okay, so it works perfectly fine. It's showing the right letter and everything. Let's see, but there's just like the little dots there that I couldn't get rid of. I use the same code from previous lab for decoder of the hex and everything, but it just show up the little dots there. But everything works, showing the right letter, right digits, everything in order. There's a reset. If I do it again, F, just count. Okay, this is part C of lab 3. I have the reset button, which will reset the values, and I have the start stop buttons, which will stop and start the clock, and I have load, which will load the values from a parameter, and it just keeps shifting it. This start stop button, instead of stopping the clock, I was dealing with trouble for a while. I stopped the clock ladder from producing a new clock to stop the whole thing, instead of stopping the clock from in and out, because I was having trouble with that. So yeah, that's how it works. For the design, I just follow the instructions. So I have top level module calling on off buttons, which will send the signal to the clock ladder to stop or keep incrementing the values. And then have circular buffer, which will keep updating new values based on the 22 pin produced by the clock ladder. So that means if it's off, if I press on off, then the circular buffer will get affected by that as well. I also have the MUX decoder and controller from lab 2 that takes in 22 pin from the clock ladder to load the new values in and display it, and then the 17 to actually updating the hex on the screen. In case you want me to explain it, this is lab 3 part B. Here we have reset. First I set it to low and then high because that's how it works. And then I have load. I load the values. This is the data in. I just pretend that data in, we input data here at this point, and then I press load. It goes low, and it's update the data out registers, which at the beginning store 000. Now it's storing the values of the data in, and then after 1 clock cycle, the reason why this is 2 clock, because I just pretend that loads quite long. After each 1 clock cycle, this will shift to the left. Every 4-bit will shift to the left. So let's see if that's actually work. Here we have 0110. That's most significant bit. And then the second after that is 111. So we check after 1 clock cycle, we'll see that 1011, which is the second from the most significant bit, move to the front, and then the most significant bit roll back to the least significant bit. and we check one more, and we'll see that 111 from most significant bit to least significant bit, and that's 0, 1, 1, 0.